Day 90 Notes, Advanced Algebra 2. Today we're going to talk a little bit more specifically about domain and range and how we could create lists of numbers that satisfy domain and range when we're working with mathematical functions. Now remember, domain is simply a list of our x values of a function, and these are sometimes called input or independent variables. And when it comes to a graph or a picture of a function, we recognize that the domain represents how wide a graph can get. What are the numbers associated with the width of the graph? We'll show some examples of that before this video ends. Now, to represent the list of numbers that represents the width of our domain, we use what's called set builder notation, or what we call interval notation, and those indicate all of those values that are allowed. Down below we have an example of what's called interval notation here, and this would be called our set builder notation. So set builder and interval notation, this is how they look a little bit different. Again, I'll explain how those work in just a moment. One helpful way to consider what our domain values would be for a function is to think of all of the ordered pairs that could come from the graph and list their x values. Now, before we take a look at a graph, let's consider the stamp problem that we worked on yesterday. This stamp problem created a series of ordered pairs. We have 1900 paired with 2. We have 1920 that's also paired with 2. 1940, paired with 3. 1960 is paired with 4. 1980 is paired with 15. And the year 2000 is paired with 33. So if I ask you to identify the domain of this particular function, let's use set builder notation to list that. And set builder notation looks like this. We'll write a D with a colon, and we use these braces, they're called in mathematics. It's the curve with a point on it. It's kind of like a parentheses. And if we were to say this out loud, we would say the domain is the list of all x values such that x is an element of the following numbers. And I have to use a second brace here because I'm going to list some numbers. 1920, 1940, 1960, 1980, and 2000. And I use two braces at the end to close my comment. So again, our domain is the list of x values such that x is an element. This funny looking E means the word element in mathematics. So x is an element of this set of numbers. As long as x is in this group of numbers, then it's part of our domain. And for range, it's very similar. The range or codomain is the list of y values, the output or dependent variables. This represents how tall a graph can get. We can also use set builder notation or interval notation to indicate the allowed values. And again, we have to consider all ordered pairs that could come from the graph or chart and list the y values. So in this example, with this chart of first class stamp rates, our range using set builder notation would be the list of all y values such that y is an element of the group 2, 3, 4, 15, or 33. Now, on occasion, we can abbreviate this. This sort of notation that we use here, this set builder notation, when it's written formally like this, is nice for advanced math topics. But here, if we're talking about real-world scenarios and we're talking about numbers in the real world, we can sometimes abbreviate that set builder as well. And we can say something like this. Domain would be just this portion, 1920, 1940, 1960, 1980, and 2000. And we would say something like this, that the range in its abbreviated form is 2, 3, 4, 15, and 33. There will be times when we would want to use the full set builder, and there will be times where it's appropriate to use the abbreviated form of the set builder. Most of the time, though, I will let you use the abbreviated form if it's necessary or applicable. Now, when it comes to graphs of polynomials or other functions, we have to be a little bit more careful with how we list our domain and range. In this example up here with our stamps, we had what we call discrete values. We had exact numbers given to us for us to decide what our domain and range would be. However, when we're thinking about the domain and range of this particular function, we have to be a little bit more careful. For example, if I start thinking about this coordinate here, this is the coordinate 0, 0. I know that 0 is an element of the domain, and 0 is an element of the range, because that's our x and y values. If I start thinking of this point here, that's a domain value of -1 and a range value of -2. And over here, that looks like it's a domain value of -2 and a range value of -4. I can move to the right and pick a series of points. And I can keep moving to the left and continue to pick a series of points and create a list of these numbers. However, it would be impossible for me to list all of them, because anytime that I pick a point, I can always zoom in and pick another point that's somewhere in between, and then zoom in again and find another point in between those, and in between those, and in between those, and so on. And we can do this an infinite number of times. So to list a domain and range like this, where we have discrete values, would be impossible for us to do. And that's why, again, we use this set builder notation. So what we might say instead for the domain, and hopefully you would recognize this, that no matter how many numbers I include, I can pick any x value in this coordinate grid. Any x value, no matter how small, can be included in our domain, and any x value, no matter how big, can be included in our domain as well. I could pick the number -100 or -1000 or -0.01 or positive versions of all of those numbers too, and they will always be included in this domain. So for our domain values, we must say that the domain is the list of all x values such that x is an element of the real number system. That's what this double bar R stands for. And in my notes, it looks like this. That's what the computer generates. For me, when I write this on the board or on the overhead, or when you write it in your notes, you can write this with 2 vertical bars and then write the rest of the R. That's what we call the real number system, a real set of numbers. So as long as x is a real number, that can be part of our domain. For our range, however, we have to be a little bit more careful, because the range values are going to be our y values again, but we run into a limit here. Any of these values represent different y values that exist in the range. We kind of established what some of those might be already. However, at some point, we reach a maximum value that our y value can take on. Now, I'm going to modify this drawing just a little bit to make it work a little bit more nicely. But this drawing seems to go as high as the number 1, and that's it. There are no coordinates in this drawing that will have a y value of 2 or 3 or 4. No values above the number 1 will be included in the drawing of this diagram. So if I were writing this using set builder notation, we would say something like this. The range would be the set of all y values such that y is less than or equal to 1. And this is the full set builder notation, and this is how we could write it using an abbreviated form. If we were to write this abbreviated, we might say something like this, that the domain is all real numbers, and our range is y less than or equal to 1. Let's consider some other examples. What would the domain and range of this function be? Now, the drawing isn't perfect, but what I hope you would recognize with the tails here is that there is an arrow at either end. So the behavior of this function is that it's swooping down and it's increasing, and it's still pointing towards the left just slightly as it increases in height here. So it's racing off to the higher values in our y direction, and it's also slowly creeping to the left with our x direction. And over here on the right, our x direction is constantly increasing, and our y direction is increasing as well. For our domain, if you think of all of the x values that can be used in this graph and all of our y values, since there are no gaps or holes in this graph, and this function will eventually continue to the left as far as our number line will take us, we would have to say that the domain is all x values such that x is an element of the real numbers. Range in this case is the same thing. With y values are an element of our range as long as y is an element of our real number system. Because again, any coordinate that I choose from this graph, now in this part I only see a portion of the window, but eventually the points will be continuing downward or upward in this case, and no matter what x or y value that I choose to look for, I can find it as a coordinate in this graph. This example is very similar to the last one, but it's slightly different in that the graphs have dots at the end rather than arrows. And these dots indicate that the graph stops. It does not get any larger or smaller. It doesn't move to the right or left from these end positions. So we have to ask ourselves now, what is the domain and what is the range of this function? Well, again, domain is associated with all of the x values in a particular group of coordinates. So if you think of all of the x values that can be created on this graph, the smallest x value is going to be 1, 2, 3, 4 units to the left. And the largest x value is going to be 1, 2, 3 units to the right. So our domain is all x values such that -4 is less than or equal to x, which must be less than or equal to +3. For our range, the smallest y value that we can include in this group of ordered pairs comes right here, and that's 1, 2, 3, 4 units down. And the largest y value comes from the coordinate that would be over here, and that's 1, 2 units up from the origin. So when it comes to range, we would say that the range is all y values such that -4 is less than or equal to y, which is less than or equal to 2. If we were looking at the abbreviated solution would simply be this. The domain would be -4 less than or equal to x, which is less than or equal to 3. And the range is -4 less than or equal to y less than or equal to 2. In this example, we have, again, discrete values. There are no lines that connect these graphs. So since there are no lines that connect the graphs, we're not allowed to have any x or y values in between these 2 points. So I have an x value here, 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 and here. And I have y values here, 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 and here. So let's make a list of what those domain values and what those range values might be. For our domain, the domain can be any x value as long as, or x value, such that x is an element of the group or the set of numbers. This one is 1, 2, 3, 4 units to the left. So -4, -2, +1, or +3. For our range, our y values can be any number as long as y is an element of this group, from -2 to -1 to +1 to +3. And in abbreviated form, we can say our domain is the list of numbers from -4 to -2 to 1 and 3. And for range, we would say -2, -1, 1, and 3. Notice in this case, we had to go through the trouble of listing each of our domain and range values separately. We couldn't include a whole list or a range of numbers or a series of values here using inequality symbols because we are not allowed to have any domain or range values in between these particular points. They have to exist specifically at those locations and nothing in between. Let's take a look at one final example. Let's identify the domain and range of these lists, or this list of coordinates. For our domain, the x values have to be such that x is an element of, and if we look at our x values, we have the numbers -2, -1, 0, and 1. Whereas our range would be all y values such that y is an element of this list of numbers, 1, 0, 1, and 2. Well, these got repeated, so I'll only list those one time, and I'll call this 0, 1, and 2. Notice that I rewrote these a little bit out of order from where the points were given to us, and instead I wrote them in numeric order from least to greatest. If I had asked for the abbreviated form of these numbers, the abbreviated form for the domain would have been simply -2, -1, 0, and 1. And the range would have been 0, 1, and 2. Hopefully that gets you pretty well comfortable with the concept of domain and range, as well as considering what objects are functions and not. So today we have a series of practice problems to work on, and I wish you good luck. Let me know if you have any questions, and I'll be happy to help.